Hello, my students. Today I want us to solve this question under matrix. So we've been given two matrix L and matrix M. Then we are saying find the value of x for which the determinant of L and M are equal. So now, how do we solve this? So to find the value of x, first we're supposed to know the value of we're supposed to know the determinant of matrix L. So now let's go ahead and find the determinant for matrix L. So meaning we have det L, which is equal to, so the matrix given, we have -2, -2, then 6, 7. You close like that. So now, this is how you find the determinant. You are going to say the product of major diagonal minus the product of minor diagonal. So we're supposed to multiply this one times this one, then you say minus this one times that one. So in this case, we have -2 times 7, which is -14. Then we have minus, because we're supposed to subtract. Then we have 6 times -2, which is -12. So from here now, you can see that we have two signs. So we have to get rid of one sign. So meaning we're supposed to multiply negative times negative, which is positive. So meaning we have -14 plus 12. And -14 plus 12 is the answer is -2. So meaning this is the determinant for matrix L. So now, to find the value of x in the other matrix, we are going to say we're supposed to find the determinant for this same matrix. So meaning it will be determinant of M, which is equal to, so the same way of the same way we used to find the matrix for the determinant for matrix L, we are going to use the same method to find the determinant for matrix what? M. So meaning we are going to multiply x times 2. So x times 2, which is 2x, then it will be minus. Then we have -3 times -4, which is equal to 12. So we have our 12 like that. Then since we've been told that the determinant for L and M are equal, so meaning why the determinant M it will be equal to what? -2. So it will be -2 is equal to 2x minus 12. Then from here you can collect like terms together. So meaning this number here will go the other side, will join the other number. So meaning it will become positive instead of negative there. So I have 12 minus 2, which is equal to 2x. Then we can subtract the other side. So meaning you have 10, which is equal to 2x. Then from here, we can divide both sides by 2, so that we can remain with x this side. Even here, 2. Then we can cancel. So meaning x is equal to 5. So meaning the value of x is equal to 5. So that's how we can find the value of x. Then we go ahead and find the inverse of matrix M. So now, on finding the inverse, we're going to say, so I have matrix M, which is equal to, where there's x, let's put 5, since we have found the 5. So x is equal to 5. So meaning we're going to put 5 there where there's x. So meaning we have 5, -3, -4, and 2, like that. Then after you are done now, this is how to find the inverse. So this is matrix M. So this is how we can find the inverse. So inverse is denoted by m to the power -1. So this is the inverse. So meaning the inverse of m1. So what we are going to do, in the major diagonal, you are going to swap the element. So meaning 2 will come where there's 5, and 5 will come where there's 2. And in this and in the minor diagonal, you are going to multiply each element by -1. So then after you're done, you're supposed to multiply by the inverse of the determinant. So meaning it will be inverse of this matrix. It will be 1 over the determinant. What is the determinant? The determinant, we found it as what? As 2, as -2, sorry. So meaning it will be 1 over the determinant. What is the determinant? Which is -2. So it will be 1 over -2, open bracket. And I said in the major diagonal, you're supposed to swap. So meaning the 2 will go where there's 5, 5 will go where there's 2. So meaning we are going to have 2 here and 5 here. And what do you do in the minor diagonal? You multiply by -1. So meaning -1 times -3. The answer is 3. Then -1 times -4. The answer is 4. Like that. So this is how you find the inverse of a matrix. As simple as that.